Have you had your deep blue moment yet? It's that shocking insight that the AI tool that's been on your desktop for some time now has actually got so good, it's better than you are at software development. So like Gary Kasparov, when he was beaten at chess by IBM's Deep Blue, you have your deep blue moment where your carefully cultivated skill set, which has brought you success and quite frankly a fairly good salary these many years, seems worthless now that a machine is just as good. Agentic workflows changed everything in 2026. Hi, I'm Emily Bache. I'm a software developer, creator of Saman Coaching. Welcome to the Modern Software Engineering channel. If you enjoy the video today, please press like. Consider subscribing if you don't already. We are several presenters here with a common goal to bring you great advice on the technical aspects of modern software engineering. Deep Blue is the name given to that existential dread that you can get from the way that AI is taking over in software development. This term was coined by Simon Willison and others on a recent podcast and blog. Because not long ago, the quality of the code that these AI tools would come up with just made them too unreliable for anything really important. That has changed now. More and more developers are realizing that LLMs and agentic tools can do large parts of your job, and all that syntax that you've memorized, those refactoring shortcuts that just flow from your fingers, many of those skills are becoming obsolete. And it's scary, especially if a lot of your self-image is bound up with, I'm a person who writes code. According to Steve Yegge and Gene Kim in their foreword to their book, Vibe Coding, the good news is you're not too late. Yet. Talk about FOMO. I mean, of course, they're trying to sell their book. And there's some truth in this. Things are moving really fast. Now, there are some developers who I know pretty well and I admire who are still refusing to use these tools. Not because they're scared, although they probably are that too, I think we all are, but if you ask them, they often cite ethical reasons. This is a legitimate concern. I mean, large language models are trained on copyrighted works, they exploit low-paid workers, and they consume a huge amount of electricity, water, and other precious resources. And many large language models are controlled by American tech billionaires who are not politically neutral, if I put it that way. I myself was fairly slow to take up using AI tools, partly for these ethical reasons. But now as a software engineer in 2026, I've accepted that AI coding tools are part of the job now. Much like being a member of modern society means buying new clothes, flying, eating meat. These are also questionable ethical choices. And some people do choose to avoid those things completely. And I admire that. I admire those principles. But I personally choose differently. I don't farm my own vegetables and take the train everywhere. Of course, I try and make better choices where I can, and I hope we all do. Sometime in the past few months, the AI agents got good enough that most software developers will do a better job if they learn to use them. Everyone in this business, more or less, has to face up to that deep blue moment and make a choice. Agentic workflows have changed the job. Okay, let's take the positive view. What are the skills that you already have as a senior developer that transfer well if you adopt agentic AI? First, though, I just need to pause and thank our sponsors. Equal Experts, Transfic, Octopus Deploy. These are companies that we've chosen to take money from because they align with the topics we talk about here on this channel. And we're grateful for their support so that we can keep making these videos. So please make it worth their while. Click on their links in the show notes and find out more about them. Similarly, we have Patreon supporters who also help us out. Their link is below too. Thank you to them. So what happens when we adopt agentic AI workflows? Well, one thing that springs to mind is it could affect the architecture. These things are good at coding, but maybe not so much architecture. Now, in the past, we had two approaches to architecture, the cathedral and the bazaar. It's an analogy by Eric S. Raymond from 1998. The cathedral, this model is carefully planned, closed source, managed by an exclusive team of developers, whereas the bazaar model is open, transparent, and community-driven. So the cathedral model is still here, and it was basically the only model until the internet made the bazaar model possible. And today, a third model has emerged, enabled by AI. Drew Brunig pointed this out. The The third one is the Winchester Mystery House. For those of you who are unfamiliar, this is an actual building. It's in California, and it's a huge tourist attraction. It was designed and built over a long period by someone with a keen interest in architecture and interior design, and enough money to make any and all of their ideas reality. So it's been built and rebuilt many times. All the rooms, all the kitchens, all the bathrooms, all the staircases, using the finest materials and craftsmanship. A huge amount of flair and innovation, but then newer parts made older parts obsolete without removing them. There are staircases that end in a ceiling, windows that just have to be barred up because they don't show anything on the other side, emergency quick fixes after earthquake damage that were put in and then never revisited. Is this sounding familiar? It's called a mystery house because it's just so confusing, impractical, charming, and idiosyncratic. Although every room is made beautifully, it just doesn't make sense as a whole. With today's AI tools, it's all too easy to come up with something like that. So again, I come back to the essentials of modern software engineering. According to Dave Farley in his book, Modern Software Engineering, these are managing complexity and optimizing for learning. I see a good future for those skills and that kind of expertise. Because as developers, we already know how to manage complexity through finding abstractions, making reusable pieces, keeping the code base organized and readable. And agentic AI doesn't, at the moment, do those things kind of spontaneously. Birgitta Berkler has written a great piece about what we need to do with harness engineering. We need to create guides and sensors that are specific for the code we're working on, for our team and for our organization. This is much better than trying to do prompt engineering, which is much more fleeting. Then the other part, optimizing for learning. This is where we still need to understand what's needed, listen to the users, watch what they're doing with our software, build in feedback loops so that we can adapt as we learn more about the problem we're trying to solve. So behavior-driven development is a key skill set here. Now, I've talked about this deep blue moment and the realization that some of the things you know how to do are now worthless. But it is actually much harder to identify the skills that we can just drop and we no longer need. In the past, software developers needed to know things like how to make punch cards, how to manually patch them with pieces of tape. And of course, no one does that anymore, except in museums. And there may be now skills that are going to go the same way. But I'm hesitating to pinpoint exactly which ones they are. It feels a little bit too soon. And many of our skills are kind of dependent on one another, and we learn them together. I mean, for example, some people have pointed out that we're not writing nearly as much code by hand anymore. So perhaps we don't need to teach people how to write code by hand. But actually, at the moment, we're still reading the code quite a lot. And those two skills, reading and writing source code, are pretty hard to separate. Although maybe we're going to stop reading it too. I heard an interesting anecdote about a new graduate developer. He had very little coding experience, but he became very rapidly productive using agentic AI, shipping loads of features, being a useful member of a small development team. But even after some months, apparently, he still was pretty bad at reading source code. So how could that work? I mean, the critical success factors in that situation seem to be, firstly, having a strong agentic AI with project-specific harness already in place, with good guides and sensors, including tests. So he could generally rely on the agent to produce good quality code for him just from the harness. And he did a lot of pairing and observing other experienced developers as they worked with the AI tools. So he had strong mentoring in engineering skills. And in that context, it worked for him to largely drop his code reading skills. Right now, I don't want to advise you not to learn to read and write source code. I fear that future of burgeoning Winchester Mystery House architectures. And it's still early days now. Some problems will likely not surface for some time. However, this graph gives me pause. It's showing the time that a human would need to complete a task against the date at which a large language model was able to complete that task unattended. And they are getting better and better at doing larger and larger tasks without help. Notice this graph has a log scale, showing that this is an exponential improvement, that is showing no signs of slowing down. And we humans are actually very bad at intuitively grasping exponential change. So goodness knows how soon maybe reading code will become a specialist skill just for museums. We live in exciting times. Having said all that, I want to leave you with some optimism. Yes, I mean, the job has changed, but senior developers are not dead yet. You have loads of transferable engineering skills that at the moment are still needed in agentic workflows. For example, harness engineering. That's something I'm teaching and coaching a lot at the moment. I want you to face up to that deep blue moment and come out the other side. Happy coding with agents.